In this video we look at standards, what they are and why we have them. Our last video we talked about protocols. Protocols are rules or agreements on how communication should be carried out between computers on different networks. To enable communication, the message went through a series of specific and agreed upon levels using the Department of Defense model. By going through these levels, the message is prepared in such a way that it can be sent across the internet. At the destination end, the receiving computers need to work through the reverse process, with the message going through the network, internet, transport and application layer. If networks could not agree on these prescribed levels and the protocols used in each level, there could not be any communication. So protocols are agreed ways on how to convey information. Standards are agreed ways on how to do or measure something. Spend the next few moments listening to how standards are used in all aspects of our daily life. At night, we are kept warmed by a duvet, which is designed to meet standards of thermal performance. In the morning, we are awoken by an alarm clock. It worked because yesterday we installed new batteries into it, which fitted and functioned as they are manufactured to standards of size and voltage. As we make breakfast, we can boil water in a kettle we purchased last week, confident that the power plug would meet the required standard and fit the outlet in our kitchen. We prepare food we purchased from the store, confident that it would taste as good as it did last time and be safe to consume because it has been processed and handled to standards of quality and hygiene. As we set off on our day's journey, we can buy a train ticket or even swipe a credit card to get direct access to the travel network, all because of standards. At lunchtime, we may need to buy some shoes and be confident that standardized sizing will reduce the number of shoes we need to try before we can find a good fit. All through our working day, we are able to communicate, access information and perform our jobs because the systems and equipment we use have been developed and manufactured to meet defined standards of compatibility, performance and quality. From this passage, I hope you can see the relevance of having standards. Standards are designed to give buyers and users confidence that the product is safe and service will work as it should. Standards allow interoperability. That is, companies who create different products can work with each other. So wall plugs can go into wall sockets. Paper can go into the printer trays. And a pencil is able to be sharpened by a pencil sharpener. In this course, we will look at a number of wireless and wired communication standards. The wireless standards you need to know in this course are Bluetooth, 802.11x, RFID, and WAP. The wired standard you need to know is Ethernet 802.3. Devices that use Bluetooth, such as laptops, desktops, notebooks, phones, keyboards, mice and printers, etc., need to be built to use the Bluetooth standard. These devices using Bluetooth transmit a low-powered wireless signal to avoid interference at the frequency of 2.56 GHz, allowing a transfer rate of up to 3 megabytes per second. The range of a Bluetooth signal is about 10 meters or 33 feet, within which Bluetooth devices can communicate with each other. However, this signal can be boosted up to 100 meters. 802.11x is the standard for defining communication over a wireless local area network between either two wireless devices or between a wireless device and base station. The frequencies covered in these standards are 2.4, 3.6 and 5 GHz. The X is replaced by another letter, which represents the ever-improving standards of 802.11x. So the first standard was 802.11a, but over the years this has moved to 802.11n and 802.11ac. Wireless technology needs to have extra security measures in place to prevent signals being intercepted. The main security measures used are WPA and WPA2. WPA encrypts sensitive data more securely, such as authentication details like usernames and passwords with the use of an encryption key. WPA2 is able to secure the wireless environment. Wireless has distinct advantages over Bluetooth in terms of its range and the strong encryption methods that can be applied to wireless transmission. Radio frequency identification, RFID, is a standard which allows technology to identify, locate and track objects like passports, animals such as livestock, and even human beings. Unlike a smart card you will swipe for getting on and off transport, anything with an RFID tag can have its data read by a scanner. The data on an RFID card could be the same as that which is on a smart card, and will have a unique identifier for that object which the RFID card is attached to. An RFID standard will mean that a tag can hold up to 2,000 bytes or 2 kilobytes of information. The RFID card or tag is a small chip with an antenna which can broadcast its information up to 20 feet using a high-frequency radio signal. Wireless Application Protocol, or WAP, is a protocol, and we've already looked at this in a previous video. But WAP is also a standard. WAP is used to show internet content on mobile devices such as smartphones. To do this, phones need to contain a micro browser. Ethernet 802.3 is the standard that describes a technology for cabled data networks that connect software and or hardware with each other. This mostly takes place with local area network cables such as CAT and fiber optic cabling. Ethernet allows data packet exchanges between end devices, these being computers, printers, servers, routers, or others. Therefore, features of the Ethernet 802.3 standard is that cabling is used on a bus or star topology, which is a type of network design. How the cable network cards and devices are connected and communicate must follow this standard, and that protocols CSMA/CD and CSMA/CA are used to ensure that any data collisions are dealt with. This concludes our discussion on standards. Thank you for listening.